Okay, the next thing that we're going to be moving towards is our scientific notation. Again, something that you should have seen prior to now, but it is important to repeat. I like recognizing scientific notation in two different steps. We have two parts to it, okay? The first part is our number between 1 and 10, and only between 1 and 10. You must have a number. 1.5, 9, whatever it might be. You've got to have a digit in front of the decimal. And it must end 9.99. You cannot have 10 point something or any number larger than 10. So between 1 and 10 is our first part of our scientific notation description. The second is multiplied by or times 10 to a power. Basically times 10 to an exponent. And you realize, and you've seen scientific notation before, let's say we have 2.59 times 10 to the fourth, okay? Whatever that unit is, you know, you're going to see I'm a really stickler for units, but let's say we have 2.59 times 10 to the fourth meters. That's how we would describe scientific notation. Now, in recognizing scientific notation, I like to look at the exponent in two different ways. If the exponent is positive, then your regular number is larger than 1. So if your exponent is positive, then the other number that you're either converting to or converting from is larger than 1. If the exponent is negative, then your number is less than 1. So let's take a look at an example in those cases. I'm going to go ahead and use this one down here. Actually, let's use that after. Let's go ahead and use an even smaller number. Let's say I have 2.0 times 10 to the second. Now I'm going to go ahead and put meters. Really what scientific notation is a math problem. And it tells you what the math problem is. 2.0 times 10 to the second. Well, what is 10 squared? 100. So 100 times 2 is 200. So notice how really this is a math problem going from your 2.0 times 10 to the second to 200. And the same thing as if we had a negative exponent. Let's say we had 2.0 times 10 to the negative 2 meters. Again, we would be looking at 2.0, multiplying that by 10 to the second to the negative second is 1 over 100th, or 100th. So 2 times 100th is 0.02. Okay, it's 200ths of a meter, let's say. Okay, so notice that the exponent here, when it's positive, the number is greater than 1, and when it's negative, the number is less than 1. Okay, that's your math problem. Now again, realistically, all you're doing with this is a movement of the decimal. Okay, so if we have 0.000392 grams, and I want to know that in scientific notation, we're really just taking that decimal point, and moving it 1, 2, 3, 4. I would stop here at the 4 place because that's where my first number would be between 1 and 10. So I would write that as 3.92. Notice I don't write any zeros where in the front. We don't need those anymore. It's just 3.92. And we're going to go times 10. Well, I've moved it 4 places. 4. Now, don't think direction. A lot of people think when we're moving to the right, that's a positive direction, so I should have a positive exponent. Well, look at this. This number, 0.000392, is less than 1. So if it's less than 1, then the exponent should be negative. So negative 4 would be how we describe this number. Let's take a look at one. If it was a positive move, 7502900, and I want it, let's again call it grams, and I wanted to move that in scientific notation. Decimal is here, when it wasn't showing. Again, let me erase that, because you realize that if we don't have a decimal showing, it's at the end. Decimal's here. 1, 2, 3, 4, 5, 6. 6 gets me to that point where 7.5029 is between 1 and 10 again, times 10 to the, I said I moved it 6 places, 6. Think about it to yourself now. Should that 6 be positive or negative? Well, this number is larger than 1, so this should be a positive. Larger than 1, we should have a positive exponent. So that's scientific notation. I do want to remind everyone that scientific notation and using that power is not the same as writing something to a exponent. So, for example, 2.0 times 10 to the second, let's say it's meters, is 200 meters. Why? Well, again, I'm looking at my positive exponent, so I think to myself, I'm moving it 2 places. If I move it 1, 2 this way, I'm going to have a number less than 1, which makes no sense because my exponent is not negative. I need it greater than 1, so 1, 2, and there's my 200 meters. Okay, that's a different number than if I had 2.0 squared. 2 squared, of course, is 4. And if I had 2 squared meters, of course, that'd be 4 meters. So this way of writing a number and this way of writing a number is not the same. Certainly, I wouldn't want to tell my banker that I have 2.0 times 10 to the second, $200, and you tell me that I have 2 squared, $4. Not the same thing.